Hey you, welcome to Wasted Audio. Today we're going to have a closer look at the owl and how you can turn your PD patches into a polyphonic synthesizer. If you haven't watched the introduction to plugdata and compiled mode, you should definitely check out this video first. In a previous release we added the ability to program and flash devices based on the owl board. The Openware Laboratory is an open source, open hardware, embedded audio platform similar to Daisy. It can be used to create a wide variety of devices and programmed with a wide array of programming languages and frameworks. And now we can program the owl board directly from plugdata. So here we have a basic monophonic synthesizer. We receive MIDI notes, then convert those to a frequency controlling a saw wave oscillator. There's a basic ADSR envelope, and then it goes to the output. And here we have 4 controls connected with special receivers to the controls on the owl board that we'll be using. And here on the right I have 4 knobs so we can simulate the actual knobs on the owl board. So in plugdata this all works. So let's program this onto an actual owl board. So here I have the Bufacco leech, which is based on the same owl board that I showed earlier. We have 4 knob inputs, 2 buttons, there's CV controls that are normal to the knobs. There's stereo audio in, stereo audio out, gate inputs, gate outputs, and CV outputs. And then we also have a USB host port, which is really handy. So we can connect it to our MIDI keyboard and use it to play our synthesizer. So let's program the monosynth. We go to the compile menu, we pick the owl platform, and in this case it should fit on the owl2 board as well. So we'll store it to slot 2 in this case. So now it's converting the patch to C, compiling it, and then flashing it onto the owl board. And because the owl uses sysx, it doesn't need a special driver, it just uses the MIDI port on the owl to program it directly. And it should now be done. There we go. We now have our monophonic synthesizer with some envelope control. So there you go. We have a monophonic synthesizer. So as we saw, we only have 4 knobs available on the leech, but maybe we want to control more parameters. So for this, I created this little expansion patch based on the monosynth. So we still have the basic monophonic synth structure, but here there's now a special router patch where we can select different parameter layers. So here we have a subpatch that selects different layers based on the button. So it looks a little bit complex, but basically when there's no button pressed, we're on layer 0. We press the left button, we go to layer 1. We press it again, we go back to 0. We press the right button, go to layer 2. And then this way we can switch between the different layers. Then there is this router section, which uses special latch abstraction that we developed. Now this also looks a little bit complicated, but basically what happens is it has an incoming value, and it will store that value when you switch to another layer. So basically only when the current layer is active, in this case it can be layer 0, 1, and 2. When we are on layer 0, we'll send the value to this outlet. When we're on layer 1, it will send it to this outlet, and 2 to the other one. And for all the 4 knobs, we'll go to different internal parameters. And what the latching functionality does is that instead of jumping to the current value, it will only latch the value when the knob passes by the value that we want. And this way we can use our second layer, for instance, to control a filter, cutoff, and resonance. And maybe the third layer, we want to connect it to a reverb with some controls. So in this patch, we've added these extra effects on top of our basic monophonic synthesizer. So I've added a little layer switcher so that we can actually test this. So let's start our arpeggio again. Now we have to open up our filter. There we go. I want a little bit more of the dry signal. Let's change the envelope a bit. As you can see, it latches the function when we pass the old value. So say I leave the filter here, and I change the envelope, and I go back. Only now does it grab or latch to the value and then closes the filter again. So let's program this onto our Bufacco leech and see if it works. In this case, because we have a lot of this extra functionality and we also added the whole reverb, I'm going to use the AL3 board just to be safe. And let's store it to slot number 3. As you can see, it takes a little bit longer to generate the C code. Okay, so let's see how it works. I'll start an arpeggio on my Akai controller right now. And then, because all the knobs are still to 0, we have to change all the parameters. So filter. And of course, we also still have CV control. So I'm gonna add the Ginkgo Synthase TTLFO to the filter cutoff. Of course, we have all these multiple layers, so if we would switch layer, we would be controlling a different parameter. Okay, so now we have a lot more controls in our little embedded synthesizer. So how do we now go from our monophonic synth to a polyphonic synth? So here I have a polyphonic version of the same patch. And we still have all our controls, we have our node inputs, we still have the reverb, but each synth voice now is its own abstraction. So let's see if we can compare these abstractions. So here we still receive notes, we still have the strip note, we still have the saw oscillator, our envelope generator, and our filter. But all of the controls are coming from outside the patch. So we have a single inlet that using the heavy dispatch abstraction to route all of the inputs to all of these unique receive objects, so that's what $0 is, of course. And using the poly object, we can then route the MIDI notes to the different synth voices. And here I've just used very simple subpatch to easily route all of the cables to all of the synth voices. So all of the controls are going to each of the voice, but each voice will receive different MIDI notes depending on which voice is playing. And then the reverb still has all the same controls. So let's give this a little test. I'll close the monosynth. So we have 4 synth voices. Let's program this onto our leech. And we'll put this in slot number 4. This will take a lot longer because we have 4 times as many voices, so we have a whole lot more code to generate and to compile. Okay, so let's check our synth voice again. And we can also still use CV control, of course. So there you go, now you have a standalone polyphonic synthesizer running on the outboard. I hope this was useful for you to get started building polyphonic synths using the Heavy compiler. And if you like this kind of content, I hope you consider subscribing. All of the patches from this video will be available on Patreon. So if you want to support the channel and our efforts with the Heavy compiler, please join us there. Patreon members can join our Discord, get behind the scenes content and free access to our plugins. Shout out to everyone supporting us so far. Alright, see you soon and take care.